Hello dear friends, welcome back to my YouTube channel. Now in today's lecture, we are going to learn about the covalent bond, or it is also known as a Lewis Langmuir concept for your covalent bond one. Now in the previous lecture, we have learned about the ionic bond one. So there we have considered one important factor while defining the ionic bond one, and that factor was the electronegativity. There we have studied that if the two atoms which are combining with each other will have a large electronegativity difference, okay, then the electron transfer takes place between that two atoms one, okay. Now, and this leads to the formation of your ionic bond. Here we are going to learn about the covalent bond, or it is also known as a Lewis Langmuir concept one. Now here we have to again consider the same factor, electronegativity. There we have considered the large difference in the electronegativity, okay. Now if the two combining atoms have a same electronegativity value or nearly equals electronegativity values one, then obviously the electron transfer theory will not explain the formation of such molecules one, okay. Now there will be the formation of your covalent bond takes place, and this is the two participating atom, okay, the two participating atoms have same or nearly same electronegativities values, okay. Then the electron transfer will not takes place between the participating atoms one, okay. For example, if I am going to consider the example regarding this particular explanation one, H2 molecule, comma O2 molecule, N2 molecule and CH4 molecule one. Now here we know that this H2 molecule will be formed by the combination of the two hydrogen atoms one. Now obviously these two hydrogen atoms will have the same electronegativity value, that is 2.1. It will also have the value 2.1. This oxygen have the electronegativity value 3.5. Obviously oxygen molecule will also form by the combination of your two oxygen atom. Nitrogen again formed by the two nitrogen atom by combining the two nitrogen atom, and its electronegativity value is 3.0. That means both the atoms in these first three example have the same electronegativity value. Now here carbon have the electronegativity value 2.5, hydrogen have the electronegativity value 2.1. That means it is nearly equal one, okay, not exactly equal but it is nearly equal. Now in such cases the electron will not transfer from one atom to the another atom one, okay. And here Lewis introduced the new type of bond, and that new type of bond is generally known as a covalent bond, okay. Next important point that we are going to consider regarding this particular point one, we know that whenever the atom transfer the electrons, obviously they transfer the electron to HU, the noble gas electronic configuration. So here Lewis studied that here generally whenever any compound which is formed, when they have the same electronegativity value, they mutually share the electrons, okay, share the electrons. That means the participating atom in this covalent bond will share the electron one, they will not transfer the electron. Now for what purpose they transfer the electrons? Obviously to attain the electronic configuration as like next noble gas one, okay. Now you will learn about this point in the examples whenever we are going to consider the formation of your ionic bond one. Now let us consider this simple example so that you will understand. Here each hydrogen atom actually achieve the duplet. That means obviously its electronic configuration will be 1s2, or the few atoms will achieve the electronic configuration ns2 and np6. Okay, so this is the stable electronic configuration of a general stable electronic configuration of your any noble gas one. Okay, now you have to remember here each hydrogen atom have the one electron. Okay, and if this one electron is shared between these two atoms, okay, this will leads to the formation of your H2 molecule obviously. And again important thing, remember this particular hydrogen atom also achieve the stable electronic configuration as like the helium. Okay, its atomic number is 2. So this hydrogen atom have the 2 electrons one. Now this hydrogen atom also achieve the stable electronic configuration as like the noble gases one. That means these bonding pair electrons, generally these participating electrons are also known as a bond pair. Okay, or it is also known as a shared pair one, and this shared pair of electron is actually shared between these two atoms. These both atoms have a claim on both the electrons one. Okay, so obviously both the hydrogen atom achieve the stable electronic configuration as like the next noble gases, that is your helium one, and this leads to the formation of your new type of bond, and which is known as a covalent bond. The participating atoms generally in this type of bond is known as an contributing atoms. Okay, contributing atoms. Okay, the next point that you have to remember regarding the covalent bond is that the pair of electrons, which is mutually shared between these two atoms are generally known as a shared pair. It is also known as a shared pair, or it is also called as a bond pair one. Keep in your mind. Then the next important point that we already studied, that though the electrons come from the two atoms one, okay, but both the atoms have the equal claim. Both contributing atoms have equal claim on your bond pair or shared pair one. Langmuir, okay, is another scientist. Okay, Langmuir called this bond pair or bond pair as a Lewis electron pair or a covalent bond one. Langmuir actually first of all called this as a Lewis electron pair. Lewis electron pair is nothing but your bond pair or the shared pair, or it is also known as a covalent bond. So this is your Lewis-Langmuir concept about your covalent bond one. Whenever we are going to consider a covalent bond, if we have to represent the formation of the molecules one, so shared pair of electrons represented by the dash, simple dash one, and it is responsible for holding the two atoms. One hydrogen atom share its one electron with the another hydrogen atom. Okay, and there the formation of your H2 molecule takes place. either you represent in this manner, or generally we represent the covalent bond as an dash one. Okay, so this is about your Lewis Langmuir concept.